What's up, guys? Today I want to talk about lag time, and that's going to be an extension of the last video about extravascular one compartment. So we know the equation of extravascular one compartment, that C is equal to B, all this, and we know that A should be equal to B when we solve for A and B, but not if there's lag time. If there's lag time, then A and B are not equal, actually. And if you haven't watched the video before this, I really recommend watching it because it'll help you understand, everything I'm talking about. So let's take these two graphs. If we take these two graphs, we have one without lag time, one with lag time, and lag time is L. So you see that absorption happens right away. It jumps up and happens right away. Absorption here, there's some time before it starts jumping up, and it's time L. And if we were to feather this, we'd get so this is what we expect, right? Normally, this is what happens. This, and then we'll get another line here. So we got the B line, we got the A line. For lag, if there's lag time, this is what we get. We get this. We feather like that. Okay, so the next line would be you get A line about roughly here. So so you see how the lines cross and intersect? That's what happens when there's lag time. So this B line extends to the y-intercept, and that would be B, and this A line extends to the A-intercept, that would be A. So then the y-intercepts are different. So A does not equal B, whereas here you get A and B are interchangeable. They're the same thing, same y-intercept. But here they only intersect after some lag time L has passed. So if we were to do a problem, this is from the textbook. I'm not going to really go into the whole thing, but I kind of solve for it. So you get B is equal to 20, A is equal to 50, K is equal to 0.17, K is equal to 0.7. And how do we find lag time? Well, lag time is, so if I were to just take the graph from last page, and I kind of just did this is what I did. That's the A line, and I guess this is the B line. That's really bad, but you know what I mean. Okay, so B is here. You get A is right here. Then they intersect at this point, and L time has to pass. So L time has to pass before they intersect. So now we have the equation of we have two equations of lines. So let's say C A is equal to right, and we get CB is equal to B times negative KET. So we want a point. We want to find where these two lines intersect, and how do we do that? All we need to do is just set CA and CB equal to each other, because at this concentration it's the same at A or for the A line or the B line, and that similar concentration only happens when L time has elapsed. So if we were to rewrite these equations, set them equal to each other, we would get A, B, K, T, or actually it would become L is equal to B, L. And if you take the ln of both sides, you get L, and you solve for L, you get L is equal to ln A minus ln B over K A K E. So L in this case, for this particular problem, it ends up being about 1.7 hours. So if it's 1.7 hours, we can find what the C is. At what C does it intersect? And it's pretty easy to do that. So all you do is you just do CA is equal to A we got was 50. E negative Ka is 0.7. Sorry for scrolling up and down. 0.7, and then L is 1.7. And we get Ca is equal to about 15. And if we do the same thing for B, you'll find that Cb is equal to B is 20, 0.17, I believe, and 1.7 hours, and CV also ends up being 15. So that's how you can kind of check that, you know, there is lag time, because even though the actual the y-intercepts were different, you can adjust it and you can find that the actual C's are the CAs are the same. Now, in order to get the actual adjusted equation, we have to kind of utilize this stuff. So we got C, the actual adjusted equation would be C, this would be B, e to the negative, KE we got as 0.17, I believe. Time would be T minus L. A would be 15, 0.7. So that'd be it. This would be A, and this would be the actual adjusted equation after you take everything. So now this accounts for the lag time. So then boom, you wait, and then it goes up. So let's say Shao asks you, at what time, if time is 10 hours, what's the concentration? You can plug in time right away. And lag time we found is 1.7. Lag time we found is 1.7. And you solve it right away. You account for that. You account for that 1.7. So in actuality, even though time is 10 hours here, when you actually look at it, when you actually look at the graph, it would be 10 minus, so it would be 8.3. After 8.3, this is the concentration. After 10 hours, this is the concentration. But it's actually after 8.3 hours, that's the concentration. Yeah, so that's pretty much it. You can also find T max when you factor in lag time. So T max with lag time is just T max regular plus L, and that would be your T max with lag time. So we found L to be this, and T max is going to be just this. From the textbook, and you just add them together, and you'll find T max after you account for lag time.